Hey, AP Calculus kids, this is Dr. Callahan with Week 10 Thursday. How are you guys doing? Go ahead and pause the video and answer the following 3 questions for your warm-up log. All right, let's go ahead and create your assignment for today. So today is Week 10 Thursday, AP Calculus, AB, Semester 2. Today, our topic of discussion is going to be around talking about the general solution of separation of variables and differential equation. So specifically, we're going to talk about solving differential equation word problems. And so here is your instruction. Make sure you guys watch the video in its entirety. Check in with me by second period, which is 9:41 a.m. And if you have this online today, make sure you upload your assignment to me by 3 p.m. All right, so with that said, let's go ahead and take a look at your first example for today. So looking at this right here, notice how you have x and y on 2 separate sides. First thing we're going to do is we want to make sure we separate that variable. So we have y is on the left side and x is on the right side. So to do that, let's go ahead and maybe, let's go ahead and divide it by y on both sides. You have a dy over y equals, you want to get rid of that dx, so we multiply by dx, so x dx, and then you also want to divide it by the x squared plus 4, so x squared plus 4. So now that you have everything set up on 2 different sides with y's on the left, x on the right, let's go ahead and integrate this. Integral of 1 over y is just ln y, which is equal to here. I think I'm going to use a u substitution in this situation because it's not super obvious as to what it's going to be equal to. Let's have u be the denominator. So then your du equals 2x dx, and solving for dx, because your ultimate goal is to replace everything here in terms of u, is going to be du over 2x. So let's go ahead and replace this. So I have x on top over u for x squared plus 4, replacing the dx with a du over 2x, and that's perfect because what ends up happening is my x cancels, and then I have this rewritten as the integral of 1 over 2 du over u. So that looks like it's going to be an ln u as well. So we can go ahead and let's see. So then looking at this, we're just going to go ahead and do a 1/2 ln u, and again, your u in this case is x squared plus 4 plus c, with a ln y from the left side. Oops, what happened here? Share screen. Okay, that was weird. Let's go make sure that this is still on. Okay, so then let's go ahead and do the e of both sides. That part cancels. And I have y is equal to, and actually before I do the e, remember there is a rule where if you have ln a to the b, it's equal to b ln a. Well, take a look over here. You have that 1/2 right there. So If that 1/2 is b, notice how the b is now going to be behind the ln. So before I do the e yet, I want to make sure I get rid of that pesky little thing here. So I'm going to put this up here as a 1/2. So then when I answer the e, this is cancel. Y is equal to the square root of x squared plus 4 because of the 1/2. And remember that c, you just put in front of that. And if you're not sure as to why we have that c in front of it, think of it this way. If you have e to the square root of x squared plus 4 plus c, remember there's a rule in algebra where you have a to the third times a to the fourth. It's equal to a to the 3 plus 4. So think of this right here as a, think of the c as 4. So if I expand this, it's just e to the x squared plus 4 times e to the c. E to the c is just going to be a big constant, and this multiplication means that you can just bring it up to the front. All right, you guys, so with that said, let's go ahead and take a look at what we're going to be doing today. First things first, I would like you guys to go ahead and take a look at this paper here with Albert IO. I passed this out to you guys a while ago, and your Albert IO code for this class is right here. So make sure you have that available to sign on. Your Math Excel is only going to last until week 13, so you have about 3 more weeks. And then after which, for week 14, 15, you will go ahead and start working on Albert IO. So make sure you're able to log on to it successfully. And this is kind of just what it looks like. Next, we're going to go ahead and take a look at your guided notes. So turn over to your guided notes for today, for week 10 Thursday. And it should look something like this on the side. Separation of variables, rearranging equation with the x and the dy's, with the y and the dy's on the left, and the dx and the dx on the right of the equation to solve this. All right, let's go ahead and take a look at the first one then. All right, so with your first one, we're going to go ahead and solve and separate this first. So let's do the dy's on the left, multiply the dx's on both sides. So 2x dx, multiply the y's on both sides, and you have y dy. After you have that, let's go ahead and integrate this. If I integrate the y, it's a 1 plus 1, which is a 2, divided by 2. So I have y squared over 2 equals, integral this, 1 plus 1 equals 2 divided by 2, x squared plus c. Our goal here is to solve for y. So I'm going to multiply both sides by 2. Cancels, y squared equals 2x squared plus 2c. That's still like a constant. Now I'm going to go ahead and square root both sides. So y equals plus or minus the square root of 2x squared plus 2c. And this right here is your answer. And this is how we integrate with separation of variables. All right, let's take a look at number 2. With number 2, you have dy equals, I'm going to divide that, so 1 plus y equals x dx. Let's go ahead and integrate both sides. On the left side, if I were to go ahead and do a u substitution, u equals 1 plus y, du is just going to be 0 plus 1 dy. So then if I replace this, I have a du over u, so 1 over u. And the integral of 1 over u is just ln u, which is 1 plus y, equals integral of x is 1 plus 1, which is 2 divided by 2, is going to be x squared over 2 plus c. Now let's go ahead and do the e of both sides. And if I do that, I'm going to have this part cancel. 1 plus y equals e to the x squared over 2 times e to the c. Remember the power rule? So then this part right here is just going to become a big C. So y is equal to C e to the x squared over 2 minus 1. And that is your answer. All right, let's go ahead and take a look at example number 3. It says find a general solution to this, then find the particular solution, y equals f of x, and the solution passes through this point. So given the fact that they give you this point, you are able to find C once you separate the variables and integrate them. So let's go ahead and do that then. So my first step, as I'm looking at this, I have a y prime. Remember, your y prime is the same thing as dy over dx. So you have 2x plus 3y times dy over dx equals 0. My goal in this situation is to solve for y. So now let's go ahead and separate them. So I'm going to keep my 3y dy on the left side equal to, subtract the 2x, you have a negative 2x times dx on both sides. And I think this is as far as we can go. Oh, actually, I don't want to have the 3 there, so I'm going to go ahead and divide by 3 on both sides. So y dy equals negative 2/3 x dx. Now let's go ahead and integrate both sides. The integral of y is just going to be y squared over 2. The integral of x, the 2 and the 2 cancels, is going to be a negative x squared over 3 plus c. So then at this point, let's go ahead and get rid of that 2 in the denominator with the y squared. So let's go ahead and multiply both sides with 2. So have y squared equals negative 2x squared over 3 plus 2c. And at this point, I feel pretty confident that if you can go ahead and plug in your point here, you'll be able to find point C. So I know that my y is a negative 2, so that's 4, equals 1 squared is just 1, negative 2/3 plus 2c. Let's add that over. So you have 2c on the right side equals 4 plus the 2/3. If I make this a 3, this also becomes a 12, which then gives you 2c equals 14 over 3 divided by 2 on both sides. C equals 14 over 6, or you can go ahead and reduce it down to a apparently that's not correct. Hold on a second. Divided by, so then my C is 14 over 6. So if I go ahead and reduce this, I will have a 7 over 3 as my C. So let's go ahead and take a look at this equation here. You can go ahead and solve for the y squared by square rooting both sides. Negative 2x squared over 3 plus 2 times 7 over 3, which is then going to give you a 14 over 3. And that is your answer. All right, you guys, so those are your 3 different examples. And if you would like to continue on, that's completely fine. Go ahead and try number 4. Pause the video and do that. And I'm trying to give you that answer, but apparently my computer is stalling a little bit. In case this video ends, I'm so sorry. Okay, there we go. So here's your answer for 4. So take a look at the steps that I provided, and then continue on with number 5. Pause the video, give it a try, and then here's my answer for number 5. All right, so after number 5, next thing I'm gonna do is I'm gonna show you guys 8 different cards. So you could pause this video if you want to and just take a look at it. And then here's a second set of cards. So really you actually have 6 cards, just kidding. But cards set 1, card set 2. And what I want you guys to do with this is the steps are provided, but specifically what I want you to do is that on a separate piece of paper, analyze the steps of each card. What is a goal that you want to find? List all 5 steps for all the cards, like step 1, step 2, step 3, step 4, step 5, just like I have on examples 4 and 5. What is the tricky part of solving the differential equation by separation? And then what is your level of understanding? So once again, here's card 1, or set 1, and set 2. Okay, so then if you are done with that, next I have a quizzes that I would like you guys to practice with on differential equations. So I'm going to go ahead and assign this. There are 15 questions. You, of course, want to do this by today. So you have joinmyquiz.com and then insert 328-26946. And there are 15 questions for you to go ahead and answer. All right, guys, I think that is about it. Although, I'm going to take a look at your guided notes for week 10 one more time. I do have some additional examples here that you can go ahead and take a look at and go through on your own if you need more practice with it. So please take a look at this if you need more examples. I also have some questions from the textbook as well, along with the solutions. And that is basically it. All right, you guys, as always, I hope you guys stay safe and healthy, and I'll see you guys next time. Take care.